We denote this as the largest greatest common divisor that divides each individual integers. And the lemma 3.2, lemma means somewhat similar to corollary. It's a small result that comes from some definition or theorems. So in this case, this actually comes from this definition. It says the greatest common divisor of a1, a2 to an is equal to a1, a2, the greatest common divisor of a1, a2 all the way up to an minus 1, and the greatest common divisor of an minus 1, an. Well, how should we understand this? This actually tells you can group the numbers in any way that you want. In other words, you can find the greatest common divisor of these n numbers by first finding some greatest common divisor of some pairs. So one application of this result is, let's find the greatest common divisor of 15, 21, and 35. To find that, according to this result, I can group. So I can first find the greatest common divisor of 21 and 35, which gives me, so the greatest common divisor of 27 and 35, what is that? This is 7, right? This is 3 times 7, this is 5 times 7, so it's going to be 7. So I'm going to write there 7. And then the greatest common divisor of 15 and 7 will be just 1. So that's how we use this lemma 3.2. Now let's take a look at this problem. What's the greatest common divisor of 280, 500, 490, and 700? I can group the first two and group the last two. Just group any way that you want. The idea is actually if a divisor that divides any one of those, certainly that number must also divide an minus 1 an. So we can actually group in any way that we want. Now, so here, let's continue. This is 280. One way to simplify that is I see a common factor 10. I also see that 2 can be also factored out. So therefore, for the first part, I'm going to factor out 20, right? When I factor out 20, this is 14. 280 factor out the 20, you are left with 14. 500, you are left with 25. For the second part, I can factor out 70. I'm left with 7 and 10. Now, these two are relatively prime, so therefore this is going to be 20 times 1. And 7 and 10 are also relatively prime, so which is 70. And then I can factor out the 10. I'm left with 2 and 7. Therefore, this is 10. This lemma allows us to do simplify some problem using one of the earlier established results. We can factor out the common factor. So it reduces some lengthier problem into smaller, easier problems. The last one is a concept, mutually relatively prime and pairwise relatively prime. When we say mutually relatively prime, that means the greatest common divisor of this n, a1 to an, these n integers is 1. So then we call it mutually relatively prime. The pairwise relatively prime, that means if you pick arbitrary pairs, any arbitrary pair that they're relatively prime. Now let's check on these couple problems. Is the first one mutually or relatively prime? By the way, if you look at the definition, mutually is relatively weak, and pairwise is pretty strong, because if you pick any pair, they're relatively prime, so it's stronger condition. Now the first one is that first of all, it's not pairwise relative prime, because 2 and 4 obviously it's not relatively prime, right? So therefore for this one cannot be not pairwise, because 2 and 4 is not the greatest common divisor of 2 and 4 is not 1, it is 2. Now, is that mutually relatively prime? Then we can do some algebra. Yes, we are going to say, so find the greatest common divisor of 4 and 7, which is 1. And 2 and 1, the greatest common divisor of 2 and 1 is going to be 1, right? So therefore, it is mutually relatively prime, but not pairwise relatively prime. Now for this one, if we check all these 3 pairs, they're all relatively prime. Therefore, it's pairwise relatively prime for this set. Is it mutually relatively prime? Yes, because none of them have the common factor. Therefore, of course, the greatest common divisor of these 3 integers is 1. So yes for both, right? Yes for both. Now just true or false, mutually relatively prime implies pairwise relative prime. If you look at the above example, you know this is false. Just look at this example, right? It's mutually relatively prime, but not pairwise relatively prime. The bottom one, pairwise relative prime implies mutually relative prime. This is true.